Like any other mathematical model that we have done so far, the first step is to specify the decision variables. When we want to specify the decision variables, we should ask ourselves this question, that what is the answer we want to get from our navigation system. We want the navigation to tell us which road to take or which road not to take. So if it is what we want to get from our navigation system, according to everything that you have learned so far, what is the best way of defining decision variables? So please pause your video and think about it and try to write down, for example, how many decision variables do we have in this graph, in this case that you see in front of you, and also write what is that decision variable and what values it can get. To check the decision variables according to the case, we have x ij. Yi is the origin and j is the destination is a good way of describing the decision variables, similar to the previous cases that we have had. Because when we said x1, 2, it represents this arc, this road. If we say, for example, x4, 6, it represents this road, this route. If we say x35, it represents this road. So xij is the one that we define. But when we want to define what is xij and what are the values it can get. Okay, regarding, for example, x1, 2, what are the values it can get? It is 0 and 1. 0 when you don't take this road, and 1 when you take this road. So the same way we explain and describe 0, 1 values last session, we are going to do the same here. So x1, 2 is a 0, 1 variable that it is like that, 0, 1. It is 1 if root 1, 2 is taken, and here otherwise. You should do the same thing for all of the variables that we have here. But what are the variables here? We have x1, 2. We have x1, 3. We are done now with the roots that originates from 1. Let's go for the other one. We have x2, 3, as you can see. We have x2, 4 here. We have x2, 6. And just as an exercise, my friend, please do it for note 5. Pause your video and do all the decision variables related to note 5, and very soon you can see it in the video, the answer. You see the decision variables associated with node 5, x5, 3, 5, 4, and 5, 6. You need to do it for every node, and in this way you extract all the decision variables related to this graph. So here you can find it, everything that we talked about documented. Xij is either 1 or 0, as we talked about it. Thus, if Xij equals to 1, the arc from node I to node j is on the shortest route from node 1 to node 6. How did we introduce it in our explanation? We did it if that route is taken. Here it mentioned if that route is on the shortest route from node 1, that is the origin, to node 6, that is destination. And it is 0 if not. And here you can see all the decision variables that we have, x12, 13. And your textbook has done it in this way. x12, there is no other way. The reverse one, there is no x21, so it is finished. After that it goes for x13, but when it goes to x23, quickly it write the reverse one. So x23, write x32, because all of the routes that are not associated with the origin node and destination node are two-way nodes. So when you see, when here it mentioned 2, 4, here we have 4, 2. And 2, 6, since it is associated with the destination node, we only have x26, no x62. 3, 5, 5, 3. 4, 5, 5, 4, and like that. And now we have our decision variables defined. Next step, like the previous cases that we have had, is the objective function. What is the objective function? We know the objective function with this example is minimizing the distance. So then we want to write the objective function, we should find a combination between the decision variables, all of the decision variables that we have, and the values associated with them to get the objective function. Remember, your decision variables must all be in your objective function. So you put them, but what is the value that you multiply these decision variables to get the objective function? Pause your video and do your best. As you may notice, the objective function structure in shortest route problem is very similar to the assignment problem, because the decision variables are 0, 1 variables. The only difference is that with the assignment problem that we did together, we have the value associated with each decision variable, the days needed to complete that project, but here we have the distance to get from the origin to the distance. So objective function would be something like this. And you see, we have all the decision variables that we define, x13, 23, 32, 24, 42, and like that. And the associated value to this decision variable, for example, to x12, it is 25. What is 25? 25 is the length of the route 1, 2 that I'm going to show you here. You see, 25 is the length of 1, 2. Or, for example, the length of route 4, 6 is 4. The length of 4, 6 is 4. And like that, now we have the objective function. And these decision variables can only get the value of 0 or 1. If they get 0, okay, there is no value added to the objective function, and it gets 1, the distance, that is 3, will be added to the total distance in the problem. Okay, and the last phase of this modeling would be the constraints, that we are going to do it step by step. Similar to the other network models, as I mentioned before, each node is associated with a constraint. Okay, now it asks you for activity 3, write the constraint related to node 1. Let me give you a guide, a hint how to start from this. See, we start from node 1. Okay, when you want to write the constraint related to node 1, I agree with you, it's not easy to do it right first time that you are dealing with such models. So I just give you the hint, and I want you after that you try your best. See, what are the decision variables related to node 1? They are x12 and x13. We don't have any other things here. Okay, so if we want to get away from node 1, do you agree that we must take for sure one of these routes? If we want to get away from node 1, we must take either 1, 2 or 1, 3. So we must make sure that when the computer is doing this model for us, give the value of 1 to one of the things, not to both of them, because it's not possible to be at the same time on 2 different roads. So it has something to do with x12 plus x13. Think on the values and the sign you need to put here. And remember, you are in this way having a dialogue with your computer, because it is gonna think for us to solve this problem. You want to tell computer, hey computer, make sure that you use one of these 2 roads. You are not allowed, computer, to take both of these roads. You are not allowed to take none of these roads. You must take exactly one of these roads. Pause your video, try your best. Let's check the answer. x12 plus x13 equal to 1. In that way, only one of these 2 things happen. If x12 is 1, x13 will take 0. If x13 is 1, this variable would get 0. There is no way 1, 1. There is no way 0, 0. And that's the miracle of math. Let's go to the constraint of node 2. But I guess it would be a better idea to go for the constraint of a last node, destination node, because it's very similar to the origin node. Okay, it is here. Activity 6, it asks us to write the constraints of node 6. Why I'm asking you, I jumped from activity 1, I guess, to activity 6, because origin and destination, since they are a single direction, roads, the associated constraint to them is similar. So with everything you remember from the origin nodes, please apply them to the destination node and try to write the constraint.